Okay, go ahead now.
Yep. Very good afternoon, everybody, and you're all very welcome to this afternoon lunchtime presentation for a change from the BR Assessors Association. I'll give it maybe just a few more minutes there while people are starting to come in. See, the numbers are moving quickly here, so we'll give it a minute or two before we start. Hey, good afternoon, everybody. Very welcome to this afternoon's presentation, lunchtime presentation on heat pumps, very kindly presented with the help of Daikin this afternoon. Just before we get started with that, and while people are still filing in, we'll just do a little bit of BR Assessors Association homework, a bit of tidying up. So just a few announcements. We will be having our annual general meeting on the 14th of April at 8 o'clock. We'll be sending out an invite by newsletter for that. We'd strongly encourage as many people as possible, obviously, if not already association members, of course, to join and become a member and put yourself forward for roles on the committee. During this meeting, we will be nominating a new senior executive council of chair, treasurer, and secretary, to get in a position to move through that. First of all, we need a good, strong committee behind us. So, I'm always going on about this. We need to invigorate and get as many committee members as possible. So strongly encourage you to reach out to any of us about that, to either Barbara at admin or chair at BR Assessors Association, whichever way. You'll find us, all our information on our website. And please, do join in that AGM on the 14th of April. That is a week, of course, before the SEI Energy Show, where we'll be taking a stand again this year. We're taking stand 131, which is going to be in the back this year, beside the exhibition area. So we've been kind of following that exhibition area around the last couple of years, as it's always a good place for people to come and chat. So that's kind of in the back. You'll find us if you're around that exhibition area at the back of the hall. So the association has been busy since Christmas, and we have been in the business of appointing more hours to our administration team to kind of back up the committee and get more work done. We'll talk more about that during the AGM, I think. And obviously, we've been getting out our newsletter and booking CPD events like this evening, as well as, of course, addressing lots of questions and queries coming in from the assessor community. And there has been a lot, obviously, with the rollout of different grants, and everybody seems to be greeting that whole process quite positively, which is great for all, I think. So it's been busy, and we are looking at the week after the SEI Energy Show having our next CPD event. Going to be a slightly different one this time. We're going to look at running your business financially and pricing and all that area. So we're very excited about this one. We've got a really good expert lined up to do this. So they'll be giving out just stellar advice about getting your price right, making sure that we're all busy, making sure that we're not busy fools, that we're actually making money out of it, and just giving us a little bit of insight. So I think well worth taking an hour or two out of your day the last week of April to tune into that. I think it's going to be a very good one. So I think we probably have most in now that we're being going there. So this afternoon, as I mentioned, we are delighted to work alongside Daikin again. Daikin, of course, have come on before and talked about heat pump developments throughout the years. So we're delighted to have a new crew back this time. So Michael Donoghue is going to start us off this afternoon, and he is a sales engineer who has worked with Daikin's residential heating products since 2021. Based in Galway, he primarily works with consulting engineers around the country to specify Daikin, while also supporting Daikin's contractor and merchant customers in NW. I'll have to ask him what NW is. He has Northwest. Northwest of Ireland, I think, is it right? Okay. He has been involved with a range of new build retrofit projects in both the public and private sectors. He's going to then hand over to Nadish Gadia. in Daikin. He's a senior design product engineer working out of Daikin's headquarters in Dublin. He's worked with Daikin since 2023 and is responsible for overseeing design and specification on a wide range of residential and commercial projects. He also is the lead technical product support for Daikin Ireland and assists consultants and BR assessors with information required in DEAP. So he is our go-to man. So first of all, we're going to hand over to Michael to kick us off, and then Nadish later. So over to you, Michael.
Thanks so much, Stephen. Thanks everybody for joining us here today. I suppose the purpose of this presentation is to give you all an overview of Daikin's heat pumps and heat pump technology overall in the market, and then support you with a bit of information that you'd be looking for as BER assessors, that sort of thing. But I know that, you know, as BER assessors, it's your job and your role to choose a heat pump for dwellings, whether it's new build or retrofit. So I've kind of set this up to give you a bit of a background on Daikin as a company and who we are and what we do, as well as a run through the type of heat pumps, some of the technology, and where you might choose one versus the other in a certain application. So I suppose I like to start off by giving a bit of a background on Daikin as a company, because we are a very large company, a worldwide operation, but yet we just don't have, I suppose, the name recognition in the residential market as a lot of our competitors would, who are involved in, say, personal electronics, cars, and other, you know, home appliances, this kind of thing. Daikin are strictly focused on heating, ventilating, and air conditioning equipment. So in terms of us as a company, we've been around since 1924 and are now involved in a range of applications from, you know, residential heating and air conditioning all the way up to air handling units for large stadiums, including refrigeration for the marine fisheries industry. So we really cover a broad range of different markets that require heating, ventilating, and air conditioning solutions. But in terms of Daikin, just kind of as a company, giving you a brief introduction. So we've been around, as I said, since 1924. Daikin have been responsible for a lot of developments and innovations within the heating and air conditioning areas over the past century. They would have been responsible for developing the first, you know, commercial VRV system in the early 80s, which is a system that can do heating and cooling at the same time, primarily used in commercial applications. But at this point now, Daikin has become the largest manufacturer in the world of heating, ventilating, and air conditioning equipment. And that is what we focus on solely. So Daikin isn't, say, diversifying, like I said, into different manufacturing areas. They're focusing strictly on that. In terms of the Irish market and how we operate, so we are a sales branch of Daikin's European headquarters, which are located in Belgium. So they've been there for about 50 years. And that is their worldwide headquarters for design and development of air-to-water heat pump technology. So everything that we're selling in the Irish market is all, you know, tested to EN standards. It's designed, developed, and manufactured in Europe. So it's very applicable for this market. But something that makes Daikin very unique amongst manufacturers of heat pumps is that Daikin is the only company currently that develops the refrigerants used within the equipment and the compressors. So you look at the refrigerants and compressor as kind of two very essential components of the equipment. Daikin would be developing and manufacturing both of those. Most other manufacturers would be buying in OEM components for those two parts there. So I suppose it just gives Daikin a bit more insight into product development and R&D and that kind of thing. So when we look at Daikin here in Ireland, we're based in City West in Dublin. We've got an office in Cork that opened in 2024. So we're not actually installing any equipment, supporting consultants, contractors, merchants, BR assessors, and the like. But a big part of the outreach here that we do is our training in Dublin at our showroom and training facility, just getting installers, contractors up to speed on installation, commissioning, service and fault finding, all the important things they need to manage heat pump installations and aftercare. That's a big part of what we've been doing for the past couple of years as well. So Daikin, in terms of manufacturing, so the R32 refrigerant, that's currently the standard refrigerant used in the market, would have been developed initially by Daikin, and they would have been pioneers in a lot of that early technology and small HVAC equipment, really air conditioning equipment initially, and then that went into the heating market as well. The Daikin compressors, like I said, are manufactured in-house, and the compressor and the refrigerant would be, I suppose, two main components of the heat pump. If you think of the compressor as the heart of the system, it's pumping the refrigerant around the system, in a heart and blood analogy. So two very important components that are manufactured and developed by Daikin in-house. So looking at our air-to-water heat pumps and just kind of giving you an overview on the different types. So if you know nothing about an air-to-water heat pump, these are kind of the 5 basic points I like to start off with. So an air-to-water heat pump would consist of an indoor component and an outdoor component. So the term air-to-water means an air source heat pump that's transferring heat from the air outside to a wet-based system, water-based system inside, so air to water. So you have to have something outside and you have to have something inside. So an air-to-water heat pump, it moves heat. It's extracting heat from the outside air and it's transferring it to the wet plumbing system in the house. Works very similar to a refrigerator, uses a compressor, as I said, to pump refrigerant around the circuit. So if you think of your refrigerator at home as a sealed box, think of that as, your modern house. If you put something that's got a bit of warmth into the refrigerator, compressor comes on, it starts to move that heat out of that sealed box and rejects it out the back of the refrigerator. It's working in a very similar principle, similar philosophy in a home. Air-to-water heat pumps in these modern, builds and retrofits are generally low temperature systems. So you would hear talk about high temperature heat pumps, but the way that we design heat pumps here in this country is for low temperature heating systems. So you're really looking for these heat pumps to produce water between 35 degrees and 55 degrees. So that 35 to 45 would be your water temperature to feed your underfloor, your radiators, and then up to say 55 for domestic hot water needs. So think of it as a low temperature system. And then lastly, an air-to-water heat pump would be powered by electricity. But because of the principles of the refrigeration cycle, the way we're able to move heat using a compressor and refrigerant, you're getting about 4 times more efficiency than direct electric heat. So if you think of a plug-in radiator, plug in 1 kilowatt radiator, you plug that in. For every kilowatt hour of electricity going into that radiator, you're getting about 1 kilowatt of usable heat energy coming out of that. With a heat pump, for every kilowatt hour of electricity going into it, you're getting about 4 kilowatts of usable heat energy coming out of that. So the efficiencies would be far greater than direct electric. Probably a concept by now many people are familiar with, but it's still a question I get asked a lot. So important to kind of make that point. So if you look at your 2 main types of air-to-water heat pumps and the differences between the two, so you have your refrigerant split, which you can see on the left there, and then your monoblock in the middle. The main difference between the two is the pipe work that connects your outdoor component to your indoor component. In a refrigerant split heat pump, that pipe work is going to carry refrigerant. So it's going to be a small bore line, typically 1/4 inch and 5/8 inch, carrying refrigerant in and out of the house as the heat pump works through the cycle. A monoblock heat pump has water lines that connect the outdoor to the indoor unit. So everything's happening in the monoblock heat pump. The water is heated up out there and it's pumped into the house through 1 inch internal diameter water lines. So that's going to be your main difference there. There's a few other differences we can look at here. With your refrigerant split heat pump, they're rated slightly more efficient in DEAP because there's less heat losses involved with the refrigerant lines compared to water lines. The refrigerant splits would typically be slightly quicker to install as well, because with a refrigerant split, you're getting a packaged indoor unit. So a lot of the plumbing work is done for you and the connections can be made quite quickly there. A couple of benefits for the refrigerant split. So you have a lot of piping flexibility with the refrigerant split. So looking at like a small 4 kilowatt, for example, you can go up to 27 meters distance, linear piping distance from your outdoor to your indoor unit. So where you see a lot of heat pumps sitting on a footpath outside the back door of a house, that's not your only option. You can place the outdoor unit, say, behind a garage or behind a shed in the back garden, and then run your refrigerant lines through 4 or 6 inch ducting underground up into the plant room or the utility room of the house. So piping distance flexibility is a definite benefit of the splits. And as well, there's no freezing issues with the pipe work because you're transporting refrigerant from outdoor to indoors. There's no additional freeze protection that you need to consider. Looking at a monoblock heat pump in comparison, monoblock with a bare cylinder on the inside there. So it's going to be a little bit longer to install. There's a little bit more pipe work that needs to be done. Typically, a small bit lower upfront cost. You generally need to keep a monoblock about 10 meters away from your indoor components, such as your tank or your pre-plumb cylinder. You need to keep that at about 10 meters to minimize heat losses and so that you're not overstretching the circulating pump within that outdoor unit. So you need to keep the monoblock fairly close. And as well, you need to guard against freezing in the water lines outside. So I suppose a point to make there is, so long as the monoblock heat pump has power going to it, even if there's no call for heat in the house, if the homeowner has gone away for a week in sub-zero conditions, the monoblock will look after its own freeze protection. If it senses the outside air temperature getting below 3 degrees, it will start to circulate water through the pipework, put a bit of heat into it if necessary. The issue becomes if you have an extended power cut in sub-zero conditions, you need to have some way to prevent the water in those water lines from freezing and damaging the heat pump. So I've jumped ahead a small bit here, but you can see if you look at the water lines connecting the monoblock, the outdoor, the indoor, you've got antifreeze valves there. So those are just little valves that will open up at about 2 degrees outside, and they'll bleed a bit of water out of the system to prevent freezing of that heat exchanger at the outdoor unit. So that's kind of a worst case scenario. If there's been an extended power cut in sub-zero conditions, the antifreeze valves would come into play to protect the outdoor unit. So those are kind of a couple differences between the fridge splits and the monoblocks. But in terms of a functional difference, both are heating your house, both are heating your hot water tank. There's no difference on that side. So fridge splits, slightly more efficient, greater piping distances, and no freezing issues. Monoblocks, slightly lower cost, piping distance not as flexible, and then you have to keep a freeze protection in mind there. So currently, the Daikin monoblocks are only available with a bare cylinder indoors, but our upcoming Altherma 4 range, which will be launched in a couple months, will be available as what Daikin calls a hydro split. So it's a packaged indoor unit that goes with a monoblock outside. So you're working with your water lines connecting outdoor to indoor, but you've got a packaged indoor unit for ease of installation. That'll be available, I would say, in the June timeframe. And that's something that's going to be a definite benefit for the Irish market in particular. It seems to me anyway that most builders and developers and homeowners are looking for more of a packaged indoor solution. Just requires a bit less space in your plant room, and it's a tidier, neater installation, as you'll see in some pictures I have coming up here. So again, I've kind of covered some of these topics here, but you're looking at for the refrigerant splits, you've got good flexibility on your piping distances. There's different sizes available. On the left, that's kind of our 4, 6, and 8 kilowatt chassis. And then you go up to the one on the right, which is your 11, 14, 16. You know, I would say up until even about 2 or 3 years ago, we sold a lot of these 11 and 14 kilowatt units, but it seems the size of new builds now getting planning permission have come down a small bit. And I would say the 8 kilowatt, the smaller chassis, is probably our best seller for the one-off new build market right now. The integrated indoor unit comes with a standard 180 or 230 liter tank, but you can get different configurations, as you can see on the right there. You can get a wall-hung indoor box that can be paired with a larger cylinder, a third-party cylinder. If you've got existing solar thermal collectors in the roof, in a retrofit application, you can use a dual coil tank that can support solar thermal connection. So you've got a lot of different flexibility, a lot of different options there. I won't get into every option that we can do to just take up too much time, but just to kind of give you an overview. But looking at that packaged indoor unit, that's kind of really the best solution for a modern new build. It's very neat and tidy. But inside this, you're going to have things like your circulating pump. It has a 6 kilowatt backup heater. It has an expansion vessel for your space heating side. So again, a lot of these items, the magnet filter, are eliminating ancillary accessories that have to be installed around your tank. But with an integrated or packaged indoor unit, it's kind of a heating system within a box there. So as I said, it comes with the 180 or 230 liter tank. And in terms of heat loss, I would generally say it loses about 1 degree of temperature for every 4 hours or so. That's a question that gets asked a lot, but it's a highly efficient tank that can hold its temperature quite well. But I suppose the benefit of that packaged indoor unit is you don't need a lot of space internally. So in a lot of social housing developments where space can be tight on the inside, you don't need any clearance on the back or the sides of this indoor unit. As long as you can get at the black screen in the front and the top where the piping connections are made, that's all you need for service. There's no air circulation requirements around it and that sort of thing. So in this scenario here, it's slotted in next to a washer and dryer, and then through the cabinet doors above the indoor unit, you can access your piping connections and your service access and that kind of thing. So it's it's kind of been designed to that modern white goods aesthetic, right? It looks like a refrigerator. It's the footprint of a dishwasher. So it's designed to fit into a modern new build. And if you kind of contrast that with a pre-plumbed cylinder, now, to be fair, you would still need an underfloor manifold. You would still need your motorized valves, your radiator circuit, which might be located in the cabinetry above the indoor unit. But in terms of the pipe work, a lot of that is contained within the unit. So on the left-hand side, you can see 2 expansion vessels. One of those would be for your domestic hot water. One would be for space heating. The space heating expansion vessel is located within the packaged indoor unit. Same with things like your 3-port valve, diverting water from your space heating to your hot water tank. That's all located within the indoor unit. So it's a lot neater of an installation and a lot easier for a plumber or a service person to come down, maybe 2-3 years down the road if there's a service visit overdue, and they can easily kind of see what's going on within the system. And you don't need to hide it away either. It will fit into a modern kind of utility room without the requirement for a dedicated room, which you kind of would need for a pre-plumbed cylinder with a lot of pipe work and valves and stuff like that being exposed. The controls on the front of the screen are quite handy and intuitive, fairly easy to use. But one of the features I like to point out is that you can easily read your electricity consumption and your heat output on the front screen. So it's good for the homeowner to kind of keep track of what they're using. But if there's maybe a service call and the homeowner is saying, oh, I feel like my electricity bill is too high, or I feel like the heat pump is not, I guess, working to my satisfaction, this is one place where a service contractor can go in and look and just get a quick reading of how much electricity has it used, how much heat has it put out, and then, with a quick division there, you can kind of see what your rough operating COP is, how close is that number to the published data, and if it's way off, it will give the service contractor, some idea that, okay, maybe this heat pump is not running as efficiently, maybe the homeowner's got the domestic hot water set too high, or maybe there's some issue within the plumbing system itself that needs to be looked at. So this is just kind of a real world example, using a rule of thumb, the size of heat pump is a question I get asked a lot. Obviously, we can do detailed room by room heat loss calculations, but if you're an architect or you're somebody who's being asked a quick question about, okay, what size heat pump should I expect here? Because you might get 3 different heat pump sizes from 3 different suppliers, and it's good to have some idea of where your house should fall into. So the rule of thumb that we use is for a 2-story new build, we use 35 watts per meter squared. For a single-story new build, we'd use 40 watts per meter squared. And then for a retrofit brought to B2 standards, we'd use 45 watts per meter squared. So what does that look like in practice here? So I've just kind of made up a simple example. So you've got a 2-story new build, 140 square meters, we'll say. Downstairs, you've got underfloor heating. Upstairs, you've got radiators. So a fairly common setup. Important to note the temperature of the water that gets fed into the 2 different emitter types. So with underfloor heating, you can get away with a lower water temperature than you would, say, feeding radiators. And the reason is because you've got a much larger surface area. A lower flow temperature will still emit the same amount of heat as a radiator using a higher flow temperature. So that's something we have to keep in mind, and I'll explain more here in a moment. So for this example, we use our floor area times rule of thumb. So it's a 2-story new build, which I just said we'd take 35 watts a square meter. So that's giving us a 4.9 kilowatt heat load here. And that's going to be 4.9 kilowatts at minus 3 Celsius outside. And those are going to be the Irish design conditions that we have to design for. The heat pump has to match 100% of the house heat loss when it's minus 3 outside. So those are the figures we're looking at. We need a heat pump doing 4.9 kilowatts at minus 3, producing 45-degree water, and we always have to size it for the warmer flow temperature. So we'd refer to our capacity chart here. So if we look at this capacity chart here, all this is doing is simply listing the actual capacities of each model at varying leaving water temperatures. So in our case, we're going to be looking in the 45-degree column because we've got radiators, and radiators will take 45-degree water. And then we just go down the line there and we see that our small 3.5 class unit is not going to be quite enough. It's only doing 3.9 kilowatts of output at -3. The next size down, our 4 kilowatt model is doing 5.3 kilowatts of output at -3. So that's the one we'd select for this particular house. So this is just kind of a handy way to just do a quick calculation and get an understanding of where your detailed calculations for a room by room heat loss, where that should leave you. So looking at emitter types, we just talked about that a small bit, but underfloor, very common in a new build, particularly on the ground floor. It would be the best for comfort, in most people's opinions anyway. Less expensive to run than radiators because you can get away with a lower flow temperature. The lower the flow temperature that the heat pump has to do, the less electricity it's going to use to do that. In general, the warmer the water the heat pump has to make, the more expensive it will be to run. That's a kind of a general rule there. So the underfloor heating allows for that low and slow approach to heating. But I will say that your underfloor should be set up for weather compensation. So weather compensation is simply a way for the heat pump to modulate its flow temperature based upon how warm or cold it is outside. So as I mentioned in a previous slide, we designed that underfloor for 35-degree water. And that 35-degree water into your underfloor is going to provide you with the heat to keep your house warm when it's -3 outside. But as the outside air temperature warms up, you can get away with warming the house with a lower flow temperature. So you might back that off to 30 degrees into your underfloor when it's, say, 7 degrees outside, and you're still getting that same comfort level, and it's costing less money. So very important for underfloor heating to be set up for weather compensation. In my opinion, leaving underfloor heating on a fixed flow temperature, meaning it's doing the same water temperature all year round, is just a waste of electricity. Radiators, slightly different. You're often seeing radiators on the first floor of a new build. Some retrofit projects, you might need to upsize the radiators if they're coming off, say, an oil boiler that's been putting 60 or 65 degrees into a radiator. You might need to upsize that radiator so it's giving you the similar heat output at a lower flow temperature. But for radiators, we would generally leave those on a fixed flow temperature. And really, that's for user comfort, right? If you're modulating the flow temperature based on how warm or cold it is outside, the radiator is going to feel different to the touch from one day to the next. Or it could, we'll say, if it's 0 degrees tomorrow and then it's up to 10 degrees the following day, your radiators are going to feel different as you touch them. So with radiators, we typically leave those on a fixed flow temperature. It's giving the same feel to it and same output no matter what. It just, I suppose, in terms of user comfort and peace of mind, we're finding that's the best option. And then lastly, in terms of emitter types, so underfloor and radiators are going to be pretty much your two standards. But you can do fan coils as well, hydronic fan coils. We call them heat pump convectors. So they can do heat, but they can also be paired with a reversible heat pump, which just makes cold water in the summer. And it's a way to get a bit of spot cooling out of an air-to-water heat pump without having a separate dedicated air conditioning system. So it's a question we do get asked a lot nowadays, especially considering new builds with a lot of glazing are prone to overheating, particularly on south-facing sides of the building with a lot of glazing let in the sun and let in the views. You can get some overheating in those rooms, even when it's not all that warm out. So the heat pump convectors, you could also call them hydronic fan coils. They're fed by 3/4-inch water lines, and they're available in different styles. So in this particular house here, the picture on the right is from a showroom. So we'll look at the picture in the middle with the high wall unit there. That's a single-story house. It's a bungalow. Builder that I worked with in Galway there was one of the first projects that we had done with these. He's got underfloor heating throughout the house for his space heating, but he put 4 of these wall-mounted units around the place to get a bit of spot cooling for his main open-plan kitchen, living, dining area that had a lot of south-facing glazing, and then he put one in his master bedroom as well. So it's a way to get a bit of spot cooling in certain rooms without having an additional system. So something to keep in mind if you're asked about cooling, it is an option we can do. Our current range of heat pumps are all available as a reversible option. The next range of all thermophoric heat pumps, it'll come as standard, but it's something we can do. We have a concealed unit as well. It can go into a bulkhead. There's different configurations in terms of the physical positioning. The picture on the right there is an ICF house. It's recessed into a false ceiling with your supply and return connections being the only thing that's visible there. So there's different options there for for what you can do. Some people don't want to see the unit on the wall or down low on kind of a floor mounted fan assisted radiator style. They'd prefer a concealed option. Just a quick schematic here as to how this all goes together. So on the left-hand side, you've got your packaged indoor unit, your flow and return lines heading out to your space heating circuits, your underfloor, your radiators. To add in your fan coils, you simply tee off that main flow and return, and you have a dedicated fan coil circuit doing your cooling in the summertime. So when that happens, you've got a shut-off valve that completely closes down your radiators and your underfloor, and it's just feeding the fan coils. And the reason we do this is because if you're putting cold water into an underfloor system, you can run the risk of developing condensation on the floor, and it's not that effective either. The cool air will kind of stay down on the ground. So we typically recommend if you're going to do cooling, have a few fan coils around to handle that. So that's kind of a rundown of the different air to water heat pump types. Now, air to air is something that's continuing to kind of grow in popularity, and I think it will continue to grow, especially with the increased grants for an air to air system. They're quick to retrofit. So an air to air system would have no water connections at all. It's not tied to any underfloor heating system or radiators. So it's going to be strictly refrigerant lines connecting your outdoor heat pump to your indoor components. So the Multi Plus is what we call our air-to-air system with domestic hot water attached. It's kind of a newer sort of interpretation of multi-split, which has been on the market, forever. Lots of different manufacturers do multi-splits where you've got your one outdoor unit and, say up to 5 indoor emitters just doing heating and cooling. But the Multi Plus adds hot water to it as well. So I think this is really going to be popular for back garden chalets, granny flats, log cabins, apartments, any type of small dwelling, we'll say, is going to be applicable for the Multi Plus. So again, like I said, you're avoiding the use of any wet system within the house, radiators and underfloor and that kind of thing. So it's ideal for small dwellings. It's going to be more cost effective to operate because you don't need to maintain any space temperature with an air-to-air system. They're quick response. You can walk into your house after being out all day and flick on one of these emitters, and your sitting room is warmed up in, say, 15 minutes or so. That's kind of contrary to an air-to-water heat pump, where you're generally getting your best running costs by running it consistently, keeping a fairly even space temperature for best results. With an air-to-air system, you can afford to run it in more of an on-off fashion without paying the penalty on the electricity bill. So that's just something to note there. But as I said, minimally disruptive to retrofit because you're running the small bore refrigerant lines around. So we would see these on some retrofits as well. This is a recent one we had done here. One of our contractor dealer partners will say had done this. I believe this was in Kildare. It was a social housing dwelling where you've got these indoor emitters around your 3 or 4 different rooms paired with your hot water tank. And as I said, this is kind of an updated version of the multi-split, which has been around forever. Just something that we can do heating and cooling with. I think that the version of the multi-split with the tank, the Multi Plus, is just a bit more, I guess, sensible in terms of retrofitting projects for small dwellings. Because if you've just got an air-to-air system with heating and cooling, you're still going to need hot water in some way, shape, or form. The air-to-air, the multi-splits here, just doing heating and cooling, may be more applicable for light commercial applications. So in terms of sizing the heating systems, there's all different ways that we can do it. We can work with a hand-drawn sketch with dimensions and windows and doors shown on there. Sometimes we'll have to go out and measure up, like avoid a property for a city council or something like that, where we go out and actually physically measure the space and get a radiator schedule. But ideally, a dwelling technical assessment is the most ideal way for sizing a retrofit project in that way. But we can work with either option, I suppose. But what we do with this information when we go into Heating Solutions Navigator, which is our heat loss program, heat loss software, or I should say heat loss platform, because it's an online-based system. But we basically just build out room by room heat loss. You're going through each individual room, you're entering in your dimensions, your windows and doors, And then you're getting a room by room schedule for your heat loss, which we can then use to specify a radiator schedule or underfloor. On a retrofit project, when you're looking at existing radiators, we can resize them for their output on a lower flow temperature. So in this case here, we can see that, well, in this particular sample dwelling, that bar the main bedroom, every room is going to need a radiator upgrade because the radiator output at a lower flow temperature provided by a heat pump is not going to be enough to max the heat loss of that particular room. So this is all information that we can, put together in Heating Solutions Navigator and provide that to contractor or assessor, whoever needs the information. So just to kind of give you a look at what we can do. Nandish will talk a little bit about Heating Solutions Navigator as well. In terms of controls of air-to-water heat pumps, just to give you kind of a rundown on that, we've talked a small bit about this as well, but a space thermostat would be your most common method of control. So essentially, you're just setting your space temperature. When it drops below that sub point, it's going to send a heat demand signal to the heat pump to call it on. In terms of room thermostats, I would generally advise folks to minimize the number of thermostats they have in the house. Once you're getting up to 5 or 6 stats or more in a house, you can run into situations where you've got micro zoning going on, where you've got one stat calling on and calling off, and it's requiring the heat pump to just heat a very small area. The heat pump is going to quickly reach that temperature and then kick off. If that thermostat then calls again, a few minutes later, heat pump comes on and comes off, comes on and comes off. So I would generally recommend to minimize the number of stats you have around the house. Maybe one downstairs and one upstairs, or if you've got a room with a lot of solar gain, you might put a stat in there if it's prone to overheating. But generally, minimizing the number of stats will give you the best results. On-off control, something you can do with an air-to-air heat pump, but we would advise avoiding on-off control with an air-to-water heat pump. You'll get much better results in terms of comfort and efficiency by maintaining the indoor space temperature at a fairly consistent level. But as I often say, there's a lot of different factors that can affect your energy consumption, your own usage patterns, how often you're in the house, are you working from home and needing it to be warm all day long, your flow temperatures. There's a lot of different things that can come into play there. But in terms of a temperature setback for unoccupied periods or an overnight, we typically advise a 1 or 2 degree temperature setback on your space thermostats. But your external room thermostat is going to be your most common method of control. You can use third-party stats around, a few of them around the house, to zone the house like that. For single zone apartments, we can provide the Madoka stat. It's got a few energy efficiency features that are handy, like room compensation. It's basically slowing the pump in the unit as you get closer to set point. We don't see that too often in this country, especially in one-off new builds. They wouldn't be applicable for the Madoka. And then there's other options such as leaving water temperature. I won't get into that here now, but that is a very efficient way to operate a heat pump. That would be a talk for another day. On the domestic hot water side, the most common way to do it is reheat only. So this is the way we'd set the hot water tank up at the commissioning phase. The tank is basically looking after itself in this sense. So with reheat only, you'd give the tank a set point, say 50 degrees. You'd give it a drop temperature, or also known as hysteresis, of about 10 degrees. So when your domestic hot water tank is reading 40 degrees, the tank reheat kicks in. So it's a way to ensure that the tank is kind of always topped up, so that if somebody's looking for, they're taking 3 showers in the morning and then looking to wash some dishes in the afternoon, they're not waiting for the next scheduled reheat of the tank. Of course, you can schedule the tank to reheat if you really know your usage profiles. You can schedule it to top up in the middle of the day if you've got PV in the summer. So there's different ways you can do it, but generally reheat only is going to be the most, most effective in terms of user comfort, user satisfaction. And then aftercare as well, just kind of a final point on this here in terms of what we can provide. So Stand By Me is our after sales platform, and that's where all of our installations will be registered. And that's where warranty gets tracked, service history gets tracked. It can be a good thing for councils as well. We have some councils that have, we'll say, kind of a key account, and they can see all their Daikin installations throughout their housing stock. And it's a way for them to kind of easily keep track of that all. And then the eCare app is what is used for installation and commissioning by contractors or commissioning engineers. And that's just kind of a streamlined way at the end of the project where commissioning and the commissioning cert, it always tends to be, a delay or can't be gotten quickly. And it's always a panic to get that. The eCare app is just kind of streamlining that, we'll say the end of the installation process. So that's kind of a rundown of the air-to-water heat pumps, air-to-air heat pumps, kind of how they work and a few tips about them. I'm going to hand over now to Nandish, who will talk you through a few slides in terms of information applicable for you as BER assessors. Nandish, just let me know. I can kind of click through these for you.
Yeah, so first of all, welcome to the seminar, and we'll just go through how you can download the Ecodesign data of our Daikin heat pumps using our Daikin website. So this is the link. So on this link, we have all of our Ecodesign data available, whether it's air-to-air type of a heat pump or air-to-water type of a heat pump. You can just click on this website. As you can see on the screen, the energy lot 1 and 2, that gives us the energy label as well as the Ecodesign data sheets, declaration of conformity, and all the documents which are required for the BR assessment, as well as fulfilling the DEAP input data available on that link. When you click on the generate report option, it will take you. There are two lots as mentioned, like the lot 10, which is used for air to air, and the lot 1 and 2 for the water based system. You can click on either of them based on the system you have in the house which you're assessing or the data you require. And when you click on one of those links, it would ask you to fill in the preliminary information about the heat pump models. Mike, could you click next? So over here, let's say this is the example of an air to water heat pump. So when you click on that, it would ask you to select whether it's a combined heat pump or are you just looking for the space heating data? Does it have a domestic hot water separate or an integrated unit? So you can define all of them through the model input, like select the heat pump range. So if it's an Erga series, you will find generally this model number on the uh, outdoor unit of our heat pump. Then you can select the exact size of that heat pump. Then it would let you choose the indoor model as well. If you see the third option, the EHVH, which is our integrated tank option. And then if you click on next, it would take you to the page where you can see all the data available, like the energy label, product fiche, and the technical fiche for the combination of the unit, as well as separate information which is required for the tank is also available on that link. Separately, what we have done specifically for Ireland is we have made our packages. So this is the heat pump information, as you can see on the left, the Ecodesign data, and on the right side, if you see, this is the whole package which we have made, specific sheet from which the BRSSR can directly find all the data which is required for the DEAP software in one sheet, as well as, let's say, if you are confused with our model numbers and if you want to download for a whole common range, we also have that kind of package on the right hand side. If you see the picture on the same link, this are also available. Let's say if you are looking for the Ecodesign data around our refrigerant split series of the small ones, 4 to 8 kilowatts, you will find this link as well on our webpage, by which you can just click on the download your data and it would download all the Ecodesign data, technical fiche, product fiche for all the heat pump ranges, whether it's heating only, reversible, or bi-zone for the 4 to 8 kilowatt size. Similarly, there are packages which we have made for the monoblocks for our larger heat pumps as well. You can find them, all of them, on our website. Could you click next? Now, one of the major changes of the data which is required for the BR assessment or for the DEAP input now is the P-rated values, which they are asking in the domestic hot water regulations or the standards. So this is the formula using which you can calculate the P-rated value. So it makes the main information which you require to work out on this formula is the domestic hot water, which is the tested value at V40 or the domestic hot water tested value, and the reheat time or the heat up time, which is in seconds. And this data is also available easily on our Ecodesign data sheets. Mike, could you click on next? So if you see over here, the heat up time, we usually have it in hours. So it's 1.34 hours. So you need to convert that into seconds to make use of that into the formula. As well as if you see the volume of domestic hot water accounted in the test, 238 liters, that's the value which you need to put into the V40 over there. And it would give you the answer in the P-rated value or the kilowatt value of the domestic hot water for that particular heat pump. So this is one of the information which I would like to share. Apart from that, there are a lot of questions which are regarding our heat pump manufacturing number as well as the model number. We have a heat pump which are of E series, we have of D series, but a lot of time if you see, I would say the example which is in front of our screen, EHVH04S E6V. But on the site you would be finding that it would be EJ6V or EA6V. All of them are of same series. It's just the A, J, this kind of the letters, they are represent our manufacturing number. So because of that, you will find some discrepancies between the Ecodesign data provided, or you will find on our website and the actual manufacturing number which you have on site. So most of the time, the different types of the manufacturing numbers are covered in one of the documents, which is also there as a part of our package known as Declaration of Conformity. But if you don't find it, it's all right. You can use the same data, or if you require particular letter from our side, we can also give you the letter based on the project specific requirement. And I would like to also share my screen and would go through the HSN slightly more in detail. Just a second. So as pointed out by my colleague, we also have a HSN Heating Solution Navigator, which is a tool which we mostly use to accurately size the heat pump using room by room heat load calculation. It is a part of our SBM online platform. So when you go through that, it would first give you a lot of filters on the right hand side, that what is the type of the emitters you are looking for. Are you looking for low temperature application? Are you looking for a high temperature application? Do you want fan coils? If you select the fan coils, it would automatically give you the options which are compatible with the fan coils, as well as you can see in case if you require space heating only, or do you require cooling as well, or is it requiring heating and domestic hot water. So based on that, it would filter out the heat pumps for you. You can also select the options whether do you require, is it for a new property or is it for a replacement, solar thermal compatible is required or not, is there any energy source available previously, or what kind of heat pump are you looking for. Based on that, it would filter out the options and then it would give you specific type of the heat pumps available. It is not necessary to filter out in the start. You can do it at the later stage as well, depending on what type of the heat pumps are you looking for. So over here, you can see the function of the domestic hot water or the cooling. Is it required or not? What type of property is it? Does it have a complementary heat source or not? As well as the solar thermal is required or not. So when you go on to that further, the first option it would ask you is to select the zones. How many zones are going to be there in the house? Is it a single zone? Is it a dual zone? There would be two zones like you can see on the screens. A zone with a underflow heating and a fan coil, or a radiator and a fan coils, or both double underflow heating zones, as well as there are different types of the control options you can select from. Is it the Daikin Madoka control you're using? Are you using the living water temperature control or the external thermostat controller? Most of the time, the external or the third party thermostat is being used with our heat pump. So let's come on how we design the heat, or how we calculate the heat loss for our houses. So there are been standard temperatures which are mentioned on the SEI website or the SR50, that the particular room should be having particular temperatures. For example, the living room, we always design at 21 degrees Celsius. Kitchen dining is at 18 degrees Celsius. Ensuite bathrooms are also at 18 degrees Celsius. Bathrooms are at 18. Bathrooms are at 22. Lobbies and corridors are also at again 18. Similarly, there are different air change rate which have been defined to be used depending on the if it's a new build property, if it's a retrofit. So we make use of all that information. As you can see, this is how our interface looks like. You can add on room by room. You can pick up the room. You can name there, whether it's a hall, kitchen. It's the example which you are seeing in front of you. It is a dual zone in which the main zone is served with the underflow heating and the additional zone contains the radiators. So depending on the room, it would also provide you the reference temperature. Let's say for the bathroom, it is automatically giving you the 22 degrees Celsius is the standard. You can change that as well. And if you go inside, it would give you the options of doing a quick heat loss as well. If you go for a simple, it would allow you to define the floor, ceiling, as well as the all the types of the walls of the living room. You can select the surface area, or you can enter it, enter the room name, what are the adjacent rooms, and all that data. As well as if you see the U values over there, we a lot of times we make use of the U values which we get from the BR assessment report. You can change this U values, as well as it also has some inbuilt U values depending on the standards which are being used. As well as on the top of that, there is a value where you can enter the air change rate, which is usually 1 for the dry rooms and 1.5 for the wet rooms. So this is the example in which you can enter whether there is thermal bridging or not. It also gives you the option to enter the windows for the external walls, as well as it has a roof glazing option if the ceiling is exposed directly to the outside. And then once you have entered all this data, you will have a heat load in front of you. As you can see, for the current example, the heat load is coming up around 3 kilowatts. Then you also have an option in which you can calculate the radiators for the bedrooms, what size of the radiators you want. There are some pre-entered data available in case if you have a radiator from a manufacturer whose data isn't there. It's not a big deal. You can enter your customized data as well. You just need to be careful about the coefficient, which has been provided by the manufacturer, because it varies roughly from 1.13 to 1.25. Depending on that, the output of the radiators would keep on changing. Other factors which would has to be taken into consider are the output at the delta 50, or the output are provided at delta 90. Most of the time it is provided at delta 50. Seldom it is provided at delta 90 or delta 70 as well. So that has to be taken into the account at what delta it is provided, and you have to take the coefficient based on that delta to calculate the actual output at our delta, which would be differing based on the room load and the room temperatures. So there are different options of other radiators, as you can see, single panel, double panel convectors. These are the two options which we use mostly in Ireland. We hardly use the 3-panel convectors, but the option is still available. You can see the width and you can see the height which are there, as well as the panel which has been selected. And it would give you at the bottom whether the selected radiator is able to cater the heat load which is required for that room or not. It should be usually green in color, or should be always higher than the room load. Now, if you see the example on the left, at that the radiator is only giving 436 watt, which is not suitable. I would say it won't be approved by the PRSS or by yourself, because the radiator has to meet the room load or it has to exceed the room load. Either of them should be there. It should never be less than the room load. Similarly, if you enter all this data, and it would allow you to select the radiators, and you can have this radiator along with your room by room calculation in our HSN report. As you can see, if you can also do selection of the fan coil units, which is probably used for the cooling and heating as well. Mike has introduced you to the different types of the fan coil units, but you can also do the selection depending on the heat load using our HSN tool. It also gives you the heating and the cooling capacity of each of the fan coil units. Usually we do the selection for the fan coil units for heating application at a low fan speed, and for cooling application at a medium fan speed. And now finally, it would ask you to select the heat pump. As you can see on the left-hand side, you can adjust the flow temperature here once more if you want to change the setting of the flow temperature. And depending on that, you would have to select the heat pumps. Different options would be available. All the information would be provided. What is the indoor unit? What is the outdoor unit? In the function, you can see it is for the space heating and the hot water. If it was a reversible model, you will have a cooling icon as well next to that. And then you can also see that how much of the backup heater is being used to cater this load. As you can see, it is 0% of the backup heater. We usually design the heat pump, which has to run 100% on the compressor. We avoid using backup heater to cater the heat load of the house under the normal condition or the standard conditions of the design. So this is the page which you get once the report has been finalized. You can have the specification, description of the unit, literature. You can click on the literature. It would take you to our library. You can also have a preliminary wiring and the piping diagram. They are very basic, but if you require a detailed schematics or the general schematic, you can contact us directly. We also have that. And then we also have an e-configurator, in which this is mostly for the installer, in which they can see how they can configure the heat pump. They can do the configuration in detail. As mentioned, there is a weather-dependent curve adjustment as well. They can play as a simulation on this tool, how the heat pump would be working if they change the settings of the weather-dependent curve using the e-configurator option, which is available. And this is how the report would look like, a sample report. You will have a main zone, additional zone. All the rooms would have room by room calculation shown. Each of the rooms would have the air change rate value, the design temperature, and the heat load output as well. And then, as mentioned, we always try and we should always be designing the heat pump that should be covering all the heat load on itself, using the compressor rather than using the backup heater. Over here, you can see the example. It is showing that backup heater is used 5.8%, which is not the ideal scenario or the ideal case. So we would always advise to use the compressor to cater all the heat load. In case if there is an application in which it is exceeding the capacity of our single heat pump, we can also go for a cascading of a heat pump. And for that, you can contact us directly. So that's there from my side.
Thanks, Nadish.
Okay, Nadish, thank you very much for that. We'll go through a few questions, if that's okay, Michael and Nadish.
Yeah, sounds great.
What I might actually do is I might kind of start from the last one and work back, because they're kind of relevant to what we were just looking at. Might be a good idea. And I think Liam is on the call. He might keep an eye on the questions that come in from when we start here, so that we can keep an eye on them. So yeah, I'll go backwards from what just came in. So Morris asks, can we access the navigator tool? I presume he means the tool we were just looking at.
Yes, you can register with us and you can access that. It's open to all. You just have to register. We can approve
Just
it.
create
And
an account with Daikin, is it on, and you can access it then.
Yes, if you want, I will just share the link as well in the chat.
Stick it in the chat, please. And maybe the link to that thing you showed with Ecodesign data, I actually meant that might be a good one to stick in the chat as well, because people mightn't be able to click on the screen. That would be great. Liam asks, can this tool only be used with Daikin heat pumps? I presume we know the answer for that.
This is for our standby chat.
I guess the calculation tool itself is nothing to do with Daikin heat pumps, really. So in theory, I guess you could size the heat pump. Is that right? But he's asking, is it only for use with Daikin heat pumps? But
it would give you selection only option of the Daikin heat pumps, I would say, at the end. But you can calculate the heat load for general purposes as well using that tool.
Exactly, it's giving you the general heat loss, I guess. Yeah. Okay. Colin has a question about kind of specific thing on MIC connections. So he asks, if your ESB MIC increases from 12 to 16, the form that comes from ESB, I assume, asks for certain data. Do the integrated options such as the ERLA 11, 14, 16 that have no immersion load, as the Daikin spec shows their max power tank immersion as being 0, whereas the monoblock editions 9, 11, 14, 16 show max power tank immersion of 3 kilowatts.
Okay, so if you look at that data, the outdoor of the refrigerant split would not have a backup heater, but the indoor unit always have a backup heater, and that's a 6 kilowatt. I can quickly share you a table as well, or a PDF if you have time.
Sure, yeah.
Just give me a second. I'll look at that.
While you're doing that, I'll just, Barbara actually answered this question that Sean put out about watching the presentations back, but I think it was a good point for everybody to know that obviously all of our CPD events going back, I think back to 2020 or so, are all available on the BR Assessors Association website in the resources page. You go in there and you can watch them all the way back. And obviously that's for members. So you have to be a member first, which will give you a code, etc., that you can enter that area. So yeah, you can watch them all back. And anything you watch back can be recorded as an informal CPD point. So you can write that on your list for SAI purposes as well.
Just while Nandish is getting that ready there was a question from Rory about the use of cooling, Stephen, by heat pumps. Is that allowed under the SCI grant schemes? So I don't think there's any particular grant that requires a cooling load to be met that I'm aware of at the moment. Has anybody else any thoughts on that?
While you do the deep input data, it just asks you in case if your heat pump is catering cooling option or not. If it is doing, you just need to enter the seasonal efficiency ratio. Apart from that, you will never get a grant specifically for cooling. It has to be for heating. The grant is always for the heating.
Yeah,
it's not for the cooling, but it can be an add-on function.
I think the cooling inputs, and people can correct me if you're wrong, are more in the case of new builds. They tend to come in where it's mandatory to enter the cooling data. That's the way it used to be. Now I haven't looked at it in a while, Rory, to be honest. So I'll maybe just contact you directly about that.
Obviously, if it's a cooling load in a commercial aspect, it's a different grant through a CEG grant scheme or something separate. Obviously, they do
in non-domestic.
Yeah, they do fund commercial cooling and stuff like that. It's a different item, though.
Okay.
Are you finding that, Nadisha, or do you want to leave it? We don't mind.
Yes.
Just a little bit of cut.
Yeah. So this is the ESB detail form. Yeah. So as you can see for the wall hung, since the tank is separated, we always have a additional immersion with our Daikin tank to carry out the Legionella cycle. But in our Erga series, this backup or the booster heater carries out the Legionella cycle. So that's why we don't have additional load for the immersion heater, because this is served by the 6 kilowatt one. Over here you can see. Okay, these are all. This is the only available for the integrated unit, I would say, because there is one backup heater that would be serving your Legionella as well as acting as your booster heater. But when you have a separate tank, since the heat pump is not connected to it, you always require an additional 3 backup heater in the tank.
Yeah. Okay. Hopefully that answers your question, Colin, about the connection. It isn't going to require more MIC than connection if it's not being used. So I guess not. I'll go on there. It's 2 o'clock, so we'll get through a few questions quickly, if that's okay. Stephen Howland, would the embodied carbon for the heat pump only unit be different to the embodied carbon of the heating and cooling units?
What was the question? Could you repeat that?
But would the embodied carbon for a heat pump only unit be different to the embodied carbon of a heating and cooling? So I guess there's more materials obviously in the heating and cooling one, so I think it's fair to say that it would, right?
Theoretically, we need to check that with the factory, because what components would be there inside. If it's like some additional component, definitely would be there for the reversible units, but it would be for the factory to comment exactly the answer that how much is the carbon, if it's more or less, than by how much, the exact values and everything.
If I have it correct, Nandish, there wouldn't be a great difference between
there wouldn't be a great, but we don't know the exact value, Mike. That's why.
Yeah, there wouldn't be much difference now between
it's doing, of course, yeah. Okay, we'll move on from that. Adam Byrne, what common mistakes do BR assessors make when inputting heat pump data into DEAP? Or how can it be avoided? I suppose common mistakes you're hearing, Nadish?
Common mistakes, as I mentioned already, it's mostly regarding the BR assessors are confused between our material code and the manufacturing code which they find on site. A lot of time when we even share the Ecodesign data, our Ecodesign data sheet has the material code E series, so it would be E6V. But when they go on site, they come back that no, the unit which is on site is EJ6V or EA6V. So it is not same, but actually that's A or J that represents the manufacturing code or the manufacturing series, but it is the same material. And we also have declaration of conformity document that specifies that. A lot of time it covers that. But PR assessor might or might not find that easily handy. So that's a thing which they are confused with a lot of time. But yes, they can be avoided if they know the information more on that. As well as secondly, I would say, since we also have a standard Ecodesign data sheet available, that would help a lot BR assessor to avoid the mistakes, because it would have all the information which you require for the deep input on just one single sheet rather than going through different pages.
Okay, I think that would help, yeah, just rather than having to dig around through different pages to find things. I suppose it's it opens the query of why aren't all these data sheets built into DEAP in the first place? I don't know. What's your opinion on that? Has Daikin made progress with SEI in getting their data built into the HARP database?
I don't think we have made progress. We are working on that. We haven't made significant progress, but yes, it's going on.
Yeah, it would seem like an obvious way to avoid the mistakes. Like we have for boilers, we can select it from a drop down and it's all pre-populated. Liam asks, Michael, we find a lot of problems in the industry getting permission from management companies in apartment blocks who often own the balconies and have effective veto on the retrofit of air, water, and air conditioning. Can you address this point, please? So I guess landlords not allowing heat pumps to go on balconies.
Yeah. I mean, look, there's definitely a pushback in terms of siting a unit on a balcony. I suppose a lot of that will come down as well to the size of the balcony and the space available. Certainly, if it's a small footprint, I think there's kind of a minimum area that's required for human use of a balcony. So it may not be feasible to place an outdoor unit on the balcony as such, but provided there's enough space, we don't have any issues with it. We don't have any, as long as you're meeting the maintenance requirements and clearance around the outdoor unit, you need about 300 millimeters or about 250 millimeters on the back and sides and about a meter of clear space in the front, so that you've got lots of free airflow moving around that outdoor unit. There's no issue with mounting it on balconies, but yeah, certainly we've come up against that where the homeowner or the building owner is trying to avoid that anyhow.
Yeah, thanks for that, Michael. The other thing that tends to come up in that context is noise, and I'm just wondering what level of data you have on noise transmission for your heat pumps.
Yeah, we have, Nandish, am I correct in saying the noise information is on the Ecodesign sheets that we have?
Noise information is there as per the tested standard, as well as it's available on our data book. And for some of the heat pumps, let's say for Erga series, we also have a sound covers as an accessory if needed.
Okay,
thanks. We have sound covers. Typically wouldn't be using those. I think they drop the efficiency a small bit. Free airflow around the outdoor unit is critical for good operation. I didn't really get into that too much, just on account of time. But yeah, I mean, I think generally, Nandi, should be looking at about 45 decibels or so for the outdoor unit.
Yes, it depends on the model, but yes, more or less likely that.
Yeah, no. Does anyone know what the general decibel for a gas boiler was?
No.
Interesting that nobody ever complained about the oil boilers going outside their house, but
no.
The slight hum of the heat pump seems to attract some more attention. Ken asks, what savings can be expected having underfloor heating versus RADs? Well, okay, it's a kind of a calculation, really, isn't it? He's talking about a 3-bedroom house, 100 square meters, standard installation, good fabric upgrade. So maybe a percentage term of savings for between underfloor versus RADs in a well-insulated house.
I mean, is that in Nandish, when we do our heating solutions HSN reports and you're using different emitter types, is that going to give you an estimated energy usage based upon the emitter you've used?
No, it won't, because our energy estimated is based only on our heat pump and the flow temperature. But since there is not major difference on the temperature which they would be using, it would be just around 45 to 35. There would be some kind of increase in efficiency, but not drastically, I would say. And a lot of that would depend on, rather than heat pump, on how the system is installed. Even if it's a radiator or underfloor, how the circuits are installed, it is designed, it would depend on that factors as well.
So hard to say,
Hard to say because a lot of factors come into the picture. How the heat pump is being used. Is it used on the fixed living water temperature, on the weather dependent curve? Is it are the radiators being used as per design at 45, or the homeowner has changed the temperature to 55 or something like that? So there are a lot of factors, Mike, and it's difficult to say.
all things being equal, you'd expect to see some savings using underfloor instead of radiators strictly due to your flow temperatures.
Yes, if all the things are
less cycling as well. You have less cycling, not less coming on and off, and that kind of thing, because it'll be more steady state temperature. I mean, there's the comfort levels of underfloor, and not having radiators hung on your walls. There's lots of different reasons for it, isn't there? Mike asks, only a room by room. Okay, so just on the sizing, I'll start there. Kind of joint questions come together. Adrian started by saying, should the sizing not relate? This is back to your rule of thumb, I think, Michael. Should the sizing not relate to the HLI, as the BR rating can be misleading? For example, if there was PV system installed. So your kilowatts that you were saying for your rule of thumb were actually the worked out BR kilowatts. Is that right?
Yeah, look, the rules of thumb are they are an estimate. And like you said, like Mike said here, that the rule of thumb can be quite far out. It absolutely can, depending on the amount of glazing, the wall build outs. There's a lot of factors that can really throw that off. I mean, you can see a new build that's built to a certain quality down 28 watts per square meter. You can also see a new build with high ceilings and a lot of glazing going up to 45 watts a square meter. So there is a big range there. I suppose the rule of thumb is more of just an estimate that we'd be sharing with say trade merchants and contractors, just to kind of give them a shooting point. But yeah, absolutely. If you've got a sizable solar PV system, it's going to boost your BER rating, but it might not have anything to do with the heat loss of your house. So the HLI is definitely going to give us a very accurate sizing for the heat pump, and that going to that that B2 retrofit standard, that would be a figure that I'd be using if somebody off the street came up to me and said, look, we're gonna move out of our house, and it's a D or an E rated house currently, and we're going to have this brought up, we're going for the grants, and it's going to be brought up to a modern standard. Then we'd say, okay, use 45 watts a square meter as your estimate there. But it certainly can vary.
Sure. I'm just going to pick one more question from that list further up, because I'm just aware of the time here. There's two good ones. Are there any developments in COP? Can we see developments in heat pump technology that's going to increase COP? And are there case studies on your website that could indicate? I guess FEI might have them, but have we got some case studies for retrofits? And are there any developments on COP?
Yeah, Nandish, do you want to comment on COP of upcoming heat pump technology?
Yes, the COPs of our upcoming heat pump Ultherma 4, because we have made a couple of changes in the type of the compressor which we are using, and there are some of the changes in the technology. Basically, since the Ultherma 3 was launched, I would say 5 or 6 years back, Mike, if I'm not wrong.
Further even, yeah.
Yeah. So the platform for Ultherma 4 is completely new. It's slightly different, and the COPs are going to be a bit higher than what we have for the Ultherma 3 range because of the advancement in technology. As far as the case study is concerned, I don't think, Mike, we have any case studies as of now on our website, correct? We are working on a couple of them, but we don't have any on websites.
We have some case studies, but I don't think we've got anything that's in depth on an older house. Yeah. I've certainly seen more of this being looked at in the UK, where retrofits in older stone buildings are examined for their performance. But I don't think that we have anything here. I can certainly look into that.
Yeah, sure. Anything interesting there, Liam, down the other end? Maybe pick one or two.
Yeah, there are two very good ones in particular. They're all good questions, but these ones do merit a bit of attention. So Colin O'Brien asked if there's any input into the defaults that we're forced to use for heat pumps where the designer installer sign-offs are not present. And he's referring there to the fact the default has to be 8 hours, but there's no heat pump designed to operate for 8 hours, and it has a massive effect on properties. I've been to builds that get solar panels but don't have the installer sign off, and they end up with a lower BR than before they put the panels in. So again, it's I suppose a question about your advocacy there, Michael and Nandish, with SCAI, and are you sort of making representations to them about these kind of issues?
We haven't came across any case like this, Liam. I would honestly say that we haven't came across any case like this.
Right. Yeah, well, it's something that affects, I suppose, to be your community, Nandish. And what happens is as Colin says, we arrive at the house. The person's maybe bought a house that is an A2 house as sold, and then we're looking for data for the BER if they added solar panels as a retrofit or something, and we're kind of stuck. So I suppose the answer that you're given is that you've provided us with a tool there which we can use to look up any information that we can find on any Daikin heat pumps at least. So that's your support to this topic.
Yes, because on the solar panels, it has to be provided by, I would say, solar panel manufacturer of that.
Yeah, that's right. Yeah. Okay. Sorry, Colin, that's probably not the answer you wanted, but I will point out to you that it has something that has been raised by Stephen there with the SEI repeatedly in meetings with the Bar Assessor Association. So we'll just watch out for updates in the newsletter on that. The other question then was from Adam. So he said, how should Bar Assessors input large centralized heat pump data into DEAP, particularly when serving multiple units, heating and domestic hot water heat interface units are used, and flow temperatures vary depending on demand. So that's a really a good 6 marker there to finish up with today, I think.
So we have one of our system, which is like similar to what you described, the warm loop, and I'm working on closely through the SEI website, and I haven't figured out yet it completely, but since it's similar to that, we have a centralized heat pump or a district heating, which is supplying the low ambient heat to the pipe, and each individual apartment would have their own indoor unit that would be raising the temperature from the lower ambient to the required temperature of the living water in the heat pump. So I am still working, and I would say if you could give me a couple of weeks time, I could come back with an answer on that one, and I could give you a sample data input as well, that how I did the input, and you can similarly do the input for other heat interface unit.
Yeah, maybe Adam, who asked the question, can contact you directly on that, Nandish, and hopefully they'll be satisfied with your response on that one. Nice. Okay, maybe we'll do one more question. All right. So it's not sort of anything personal here, but this is a fairly straightforward one from Rory, just in relation. I think this is of interest to a lot of people. The high temperature heat pump pilot is now in place with SCAI, and Rory asked if Daikin have a product that serves that particular offer. It has to be a particular type of heat pump, 65 degrees in R290.
Yes, we do have, and I would say, Mike, could you take over and comment on this one?
Yeah, absolutely. Yeah. So I'm sure a lot of you have heard there are changes coming in terms of the refrigerant that's being used in the industry in the EU. The R32 gas that's currently the industry standard and has been for the past 10 years or so is being phased out. That's beginning in 2027. So a lot of manufacturers, Daikin included, are moving towards a complete product range of R290 heat pumps that are using R290 refrigerant, which is just propane. So that will be something that we start to introduce this summer, we'll say in June or so, and we'll continue to roll out. So by 2027, we'll have a complete range of R290 heat pumps in the Altherma 4 platform. and those will all be in the monoblock configuration. So water lines, again, connecting indoor to outdoor unit. But the refrigerant splits will not be going away. They still will be on the market. That's something that we could kind of share more information later in this year as some of these product ranges, come out. But there still will be refrigerant splits available from Daikin that are allowed to be used and installed under the way the current legislation is being written. But I would say, yeah, by and large, there's going to be a general shift towards R290 monoblock style heat pumps.
Great, thank you very much. That's a great answer. I think it answers a question Pat raised about the R32 as well. So that's all really from the back end of the questions, Stephen.
Great, thanks very much. And great to see lots of questions coming in there. And if there's something there we've missed, do feel free to pop it directly to us, chair@VR Assessors admin, and we'll answer it. Or if you really want an answer from one of the guys, if something we missed, we'll get back in contact with them and do that. There's a lot of people commenting on the designer installer sign off, and as Liam alluded to there, and Morris in the chat, the VR Assessors Association is in dialogue with SEI about this. And in fact, we've contacted our other community in the Heat Pump Association, and we've met and had a chat about that. And there's some, we are working on that because it is something I think that drastically needs to be addressed, to help the accuracy of the whole program. So we'll leave it there for now. Thanks very much to everybody. Thanks for everyone, very, very much to Michael and Nadish for taking your time and giving such a detailed presentation. It was brilliant. Thanks to all the committee for helping to organise, and Barbara, of course, who does all the work behind the scenes there. And I think that's it. Hopefully we'll see you all for AGM in April. I will be sending out a notification and a link and stuff to join that. So we'll leave it there. So thanks again, everybody.
Yeah, absolutely. You're very welcome. I appreciate the engagement in the questions, and I've just posted my email address there in the chat. If anybody has any questions they want to follow up with or any information, I can work with Nandish to come back to you on that.
Yeah.
Brilliant.
Great
Thank
stuff.
you,
Thanks,
Michael. Yep.
Yeah, you're very welcome. All the best. Take care.